Hi everyone. I'm Niloufar Agah, and yes, Andrea mentioned I'm working as a data scientist at CDC Foundation, working on some data modernization project, mostly focused on data visualization. But aligned with my routine work, I have worked independently on several AI projects, public health AI project. And in one of those projects that was initially, I called it as outbreak detection AI agent. Then later on, I changed the name because I didn't feel that comfortable to give that too much autonomy to the agent. I want to have the full control on the entire work. So I changed the name from AI agent to AI framework. And via this project, it was the first time I tried to explore RAG and incorporate it into the pipeline I developed. And it's proved to improve the quality of outcome. It was pretty effective. However, I ultimately decided not to include RAG in the final design, and due to limitation of free resources. The free resources come with some restrictions and limitations. They are good to taste the tools, but when the work is going to get a little more advanced, you need to buy the plan in some cases. And as the pipeline become more complex, those limitations doesn't let me to have a single end-to-end run. So I had to exclude that from the pipeline. But overall, I think it is a very beneficial strategy to be considered. RAG is going to improve the hallucination of LLM significantly, and going to help LLM to create a very good, a factual based and a more up-to-date response for you. So it's a good strategy to use. In this presentation, I'm going to provide an introduction to RAG, Retrieval-Augmented Generation. I'm going to talk that what RAG is, why it is important. I'm going to go over the different components of RAG pipeline and talk about each one by one. I'm going to introduce the frameworks, some of those frameworks that you can use if you want to develop RAG pipeline yourself. And also at the end, I'm going to talk about the cost and the ways and methods that you can minimize the cost or keep it as zero. So let's start. So as you know, large language models are very good at understanding language and reasoning. And they are equipped with broad knowledge, which is considered broad general knowledge. But they lack deep domain-specific expertise. For example, they didn't have access to some domain-specific data, companies' private data, internal documents during their training time. And this limitation created a gap between models' reasoning ability and knowledge required for many real-world applications. So at runtime, LLM can have only access to the knowledge it learned during the training and the information provided for it in the prompt. And if the information is not there, still is going to create a response. LLM is still going to predict the next word, but this is going to lead to poor response and hallucination that we don't want. So several approaches have emerged to bridge this knowledge gap. One of those approaches are fine-tuning. It means that we're going to take an already pre-trained transformer model and train it again on the domain-specific data set and update and adjust all or the majority of the LLM parameters. And you can imagine that LLM can have millions or billions of parameters, and updating and adjusting each is a very time-consuming and expensive work to do. So it's costly. And also, if you want to do this, you need to have access to high-quality label data set, which in many cases you don't have that specific data to that, to the extent that you need. So it would be another barrier. And also it is not ideal for fast changing information. So for areas that informations and everything change fast, you don't want to create and do this fine tuning over and over. It's became very unpractical and expensive. So it's not going to be the first choice, at the beginning. We come to the second approach that we have, and it is prompt engineering. It means that we're going to manually insert domain, some of those information into the prompt. But this comes with some issues, and one of the most important one is LLM has context window limitation. So it is very good when you have a small amount of information. It's very straightforward, easy. You can add information into the prompt and get, the relevant answer from LLM. But when you have large amount of information, because of context window limitation, that's not going to be very practical. LLM is not going to see all the information that you created to create the response for you. So and it's going to increase the risk of hallucination again. That brings us to the third strategy, which is Retrieval-Augmented Generation, or RAG. So RAG is going to provide you with access to external knowledge. And those relevant data is going to dynamically inject it into your prompt as query time. So you have external knowledge, and those external knowledge are sitting somewhere else. And RAG is going to retrieve relevant document for you and inject only those relevant information into the prompt. So again, RAG is a method that combines a large language model with external knowledge source. So model can answer questions using accurate and up-to-date information, which is an important piece of using RAG. So by using RAG, we actually can overcome one of the biggest weaknesses of LLM, which is hallucination. So their LLM tendency to confidently guess when information is missing. RAG has two main phases. One of them is retrieval, is the time that we retrieve relevant document and information. And the second one is the second phase is generation. Then we're gonna kind of use those retrieved documents in order to create the response. And we use LLM in the second phase. The first phase should be designed by us separately. So for understanding that why RAG is needed, we also need to talk about the concept of context window. Context window is the maximum amount of token that a large language model can see and process at once. And it includes both input and output token. So it includes user prompt, system prompt, retrieve documents, output, everything. And different LLM have varying context window size. For example, the context window size of GPT-3 is about 4,000 token. GPT-4 is something about 32,000. So it is vary among different LLM, but all have that specific limitation. And RAG can help that we overcome this context window limitation by, again, putting all those information, the external resources aside, retrieve those relevant, and inject the most relevant piece of information into the context window, into the prompt behind the scene. So overall, LLM has two major weaknesses. One of them, they rely on the information and the data that they use for their training, and also the context window limitation. And RAG is able to address to some extent these two weaknesses. So many of you are familiar with Notebook LM. And you may say, okay, why we need to use that? We can do the same things using Notebook LM. Upload document and get the, ask a question, get the relevant result and response. Or some of those, paid LLM model have the option that you can upload files. And in some cases, they work as RAG. So why we need to use RAG? Why we need to learn this? Why we have to go over all of those components and design it and develop it ourselves? So that's a very valid question to ask. My responses would be, using RAG, you can have full control over everything. Transparency would be another important benefit. You can see what's happening behind the scene in all steps. And it's going to give you the ability to debug errors and consequently improve accuracy. It also can provide you with better scalability. Notebook LM or other platforms may have some limitations in document size or number, or may have some limitation in the future. So it comes with some limitation. But RAG is going to allow you to handle many of large number of documents efficiently at once. And that's a very good benefit of using that. The other one would be, it can also lower long-term costs. That can be so it can be, cannot be, depends on the project that you're working on. Something that is very highlighted to me is it's going to give us the ability to integrate this with external tools and to integrate this specific concept and with external tools and workflow. For example, you can use it inside your AI agent. It can act as a tool when you're designing the AI agent. So it's a very good, for me, is a highlighted benefit of using RAG. And again, learning the fundamental, acquiring the knowledge is always valuable. It's good to know what's happening behind the scene and behind all those tools that we're using. So again, we talked about the benefit of using RAG. I'm not going to go over those again. Something I'm going to mention is it's also easy. Is the fifth one. It's easy to update. So you can easily update your external knowledge in RAG. Remove some of the document, add different ones, based on changes happening over time. So it would be another benefit of this. And we talk about the other one. We can reduce hallucination. We can allow LLM have access to up-to-date knowledge and etc. It also comes with some challenges and limitations. I prefer to call it as challenges. So first, RAG relies on your data quality in the quality of your source data. The source document. Source document can be messy, noisy, and we may not have enough technology to get the actual semantic meaning of those documents and fed into LLM. So it may be it's one of those limitations. Another one, RAG may not fully understand user intent, and that's very important. Then user intent should be completely understood, otherwise the rest of the process will be disrupted. So if the user input will be misunderstood, then the wrong information is going to be retrieved, and LLM is going to create definitely a poor response, irrelevant response for you. When it comes to chunking, embedding, vector search, indexing, those are the components of RAG pipeline. And those steps, the chunking, embedding, vector search, all those things have a specific, some items that we need carefully studied and select. And selecting the right choice, the right one, is sometimes challenging. So that's, I think, is one of the big challenges of using RAG, selecting right items for your chunking method strategies, right strategies for your chunking, selecting a right embedding model, selecting the right index type are all that matter. Another limitation of RAG would be hallucination. Still, we have hallucination. We can improve it, but we cannot eliminate that. Next limitation is because RAG has different components and stages, it's difficult to evaluate. So if we see a problem, then we have to look into different steps and to try to find where these problems comes from and correct that area. And also it requires ongoing maintenance. So it would be another challenge of using RAG, but overall is a good strategy to use. So I may skip this slide. I think I will come back to that if we have enough time. So I'm going to talk about RAG stages. So we have our data documents. We're going to introduce those data into our system. Then, for example, imagine we have 5 different PDF files. We're going to introduce and import them. Then we're going to divide those documents into smaller pieces. We call them chunk. Then those texts, those information needed to be translated in a language that is understandable by the machine, which is only numbers. So we need to come with a method to find a mathematical representation of our text. And for that, we use embedding model and we create embedding. Here we have the user query. In this user query also needed to be translated and encoded into mathematical representation. So it's needed to encode it to embedding. Then these embeddings, the document embedding, has already stored in vector database. When we have user embedding, vector database is gonna compare these user embedding with those stored document embedding and find those pieces who are most semantically relevant. And for doing so, it's going to use some similarity and distance metrics to find those most semantic relevant ones. Then it's going to select the top K relevant chunk here. It's going to send it here and may process it a little bit and then send it to LLM. And then LLM is generation part, is going to create for us the response. So the entire part, as you see here, are related to the retrieval phase. And here, LLM number 4 and number 5 is related to the generation phase. Okay, this is another demonstration of retrieval phase in RAG. So we talked about loading. Let's talk about a little about splitting. So we have our own data. Those data needed to be divided into smaller pieces. We call them chunk. And the size of this chunk does matter. And it's going to be usually determined by number of token. So if the size is small, that's not gonna be able to get everything. So we may lose context. if it's too big, so our embedding is going to be a little, it's going to blur our embedding, and we're going to have some unrelevant information, and still it may ended up to poor response. Also, retrieval may return fragments that are hard for LLM to use. So for this, we may need to also introduce some overlap. So we need to decide, okay, what's going to be the size of our chunk? What's going to be the size of our overlap? And this is the hard part. It's very experimental. So we have to experiment. Definitely there are some good tips, knowledge outside, but we need also to experiment to select a good size for our chunk, because chunking can be, it was reported kind of that it's as number one cause of poor performance in RAG. So this is something that we need to keep in mind. Okay. Then this chunk are needed to convert it to numeric vectors here. And we call this embedding. Let's go to more details about embedding. Embedding is another name for high dimensional vector. So those objects, those text, those word, sentence are needed to convert it into numeric vector, high dimensional vector. Sometimes the dimensionality can be 300, 700, thousands, so it's large. Embedding model are those models that convert text and image into numerical vectors. So something that we have to pay attention is, in this stage, we need to select the right embedding model. And it's our job to do so. The coding is not that very complex, because there are some platform and framework available, but this is our job to find the right embedding model for our data. And when it comes to classify embedding model, we can classify basis transformer-based versus non-transformer-based embedding models. So you may kind of familiar with transformers. Human was working to see that how computer can generate human language, how we can kind of translate human language into mathematical representation, how we can kind of provide this skill to computer to generate and understand language. And we had some progress, and it was good, and it goes with own pace. But suddenly, and I can say in late 2016, the idea came, and the paper published in 2017. Everything, these small advances kind of jump a lot. And when the article called "Attention is All You Need" published. And this article talked about introduced transformer, and how transformer is able to capture the semantic meanings of word and text. So that revolutionized everything, and after that, it was the time that LLM developed. So definitely the transform-based embedding model gonna be much more sophisticated than those who are non-transformer-based embedding model. But it doesn't mean that we need always use those transformer-based model, because they are computationally expensive. And we don't always need to use those very sophisticated models. Sometimes our project, in a way that we can use a less sophisticated model, we can use non-transformer-based embedding models. So this is the example of some of non-transformer embedding model. And, they are lightweight and fast. They can run on CPU with minimal memory. They're very easy to use. They are not that complicated. And, some of them, to some extent, they can very poorly capture some basic semantic search. For example, word to vec is it kind of mapped individual words to vector based on their context in the text, but it lacks kind of deeper semantic meaning, but it's still good. So you can try, and when you design your RAG, you may wish to try this as well and see how it's going to affect your response at the end. Overall, when your data is not that complex, when the data is small, the words are consistent, you don't really look into a semantic meaning of text, you can use that. For example, imagine that you want to add a document which included only the addresses. In this scenario, the semantic meaning is not that important. Those are words that has, they have their own place. So in that scenario, you can use non-transformer embedding models. And these are examples of transformer embedding models, as you see. Here, something that you need to pay attention would be dimensionality and the cost, particularly. The higher dimensionality, the more sophisticated model, but again, you don't need to use it. For example, if you look at the text embedding tree large that's provided by OpenAI, the dimensionality is about 3,000. But it is paid, you need to pay for that. And you don't really want it in, some general project, because still when you use that and you're also willing to pay, but still it's gonna take lots of memory of your system, and it's gonna have some kind of consequences on the road for you. I use, in my project, I use Almini LM-L6, and the dimensionality is about 384. It works well, and it was free. So you can consider that. But again, if you want to select the embedding model, you need to look at different scenarios, your projects, the resources that you have, and particularly something is very, very important is sometimes you have to look at your project to see if it is domain-specific project or not. Do you have domain-specific data? Or resources you're going to add are domain-specific? In this case, you need to select and go and find domain-specific embedding models for that specific project that you have. So this is something important that you need to consider. And we have many, many embeddings model that, for example, some of those on Hugging Face, and you can go to Hugging Face, type embedding here, and look into different models here. For example, I'm going to show it to you. If you go here, this is a Hugging Face. And for example, you can click on this, and you can go and read, about this model. There are some explanations. Also, there are some codes that's going to tell you how to use it. So for this, you need to import sentence transformer, and then use this function and just only enter this to use that. And there are much more explanations here in code and also in text. Sometimes there are some documentation for you to go over. And here is the place that you can go and compare different embeddings model. It's going to be a time-consuming task if you want to go over this and look into different items available. Okay. So we talk embedding. So something is important here for a splitting phase. We need to select the side of our chunk and side of our overlap. Here, something is very important, selecting the right embedding model. And you can also think about the dimensionality that you would like to have. The next part is a storage. Now, those high dimensional vectors are needed to be stored in one place. And this has its own concept, and we're going to talk about that. So, vector databases are a new generation of databases designed to handle the unique demands of artificial intelligence and machine learning workload. And there are some examples of that, such as FACE, Milvus, Pinecone, BB8, etc. So vector database, yeah, definitely, it's a storage unit, like the SQL that store your tables. Now, vector database store your embeddings. But it's not just a storage. So it's a search engine. It's also indexing system. It has some indexing system, and it has other additional components and layers. So vector database are search engines. They can find semantically similar embeddings based on distance metrics. It can be cosine similarity, dot products, etc. So as you remember, when we have those embeddings from our document, we have the embedding from the user query. Those are needed to be compared to each other. So those vector database is going to compare the user embedding against those document embedding and find those that are most semantically relevant. We call them as a similarity search or nearest neighbor search. Also, it has indexing system. It's also important part to know because we can have control on this as well. Sometimes, if you have the small data, yeah, the user in the core embedding can be compared with all of those chunk embedding that you have in your vector database. But when you have a large number of documents, your resources were big enough, so it's not going to be very efficient to go and do one-by-one comparison. So you're not going to do that. One-by-one comparison is going to give you very accurate result, but when you have a lot, it's going to slow the work. And sometimes speed is very important for a specific job, so you don't want to sacrifice the speed for accuracy in some specific projects. So for that, it is that indexing, different indexing method comes into play. So you're gonna organize in your embeddings using different methods or using different nearest neighbor algorithms to do this similarity search for you. For example, one of those methods can put everything, those vectors, into clusters, and then they try to find the similarity score between core embedding with those clusters and find the one which is most closest to your core embedding, and then go inside that clusters and find the top K chunk for you in that cluster. So you can select the type when you go over your pipeline and the code. It's the area that you can control and select your indexing type. Also, it has additional components such as comparison layer, security control, metadata filtering, etc. So overall, vector database is a complex system that manages, index, and retrieves vector embedding to enable efficient and scalable similarity search. And, when there are many options available, and it would be very, when we have many options available in the market, selecting a right one would be very overwhelming. So the one, as you see here, some of them are paid, some of them you don't need to pay, some of them can work on your local system, some of them work on the server, some of them are on the cloud. So, but or both. So there are many options with different characteristics, and yeah, it would be overwhelming to find the right one. If you're looking for the cost and you want something free, Face would be the good option because it's a library. You can, and it was the one that I used for my project. You can download it, and then you don't need to pay as long as you run everything in your local laptop. So everything is going to be free. The other one, for example, I think Niloufar, for example, the software is free, but the service in many of those cases is not free. So the cost would be maybe the important factor that you may want to consider when you want to select your vector database. In Face, if you want to select Face, you have the option to select your indexing time. You can, for example, select flat, means do comparison one by one versus other method. You can also have control on this here when you're using Face. And Face is developed by Facebook. Okay. We kind of covered the main stages of RAG. But there are some optional stages that come into play, and one of them is re-ranking. The vector database is usually do the re-ranking job. It's compute similarity or distance score, and rank candidate vectors and return the top k most similar result. The issue is relevant information may be missed if it falls outside the top k retrieved result. So the initial ranking, which based on similarity score, may not fully capture contextual relevance or semantic nuances. So for example, sometimes the 30th chunk must do better than the second chunk. So that can be the issue. So we introduce re-ranking in order to improve the performance of RAG. So we add these additional steps here, re-ranking, to do this job again. Now, instead of selecting, for example, the top 5 chunk, we're going to go and select the top 50 or 100 chunk, and then go to the next step, re-ranking, then it's going to re-rank for us. And we're going to use some more sophisticated method here. Then the method you're going to use for re-ranking can be different. You can use metadata, you can use other traditional scoring method, but the best way, to my opinion, is having a transformer-based model here to do this work for you. Look at those available options and just remove the irrelevant things and rank them based on the most relevant item, and then give this to LLM. Okay, the next component, which is optional again, is evaluation. Evaluation a RAG system means checking how well it retrieves and generates accurate, relevant, and grounded response. So accuracy, relevance are one of the important things that we wish to check. Response time and user satisfaction would be other criteria also to evaluate. So we can do evaluation in different phases. We can do evaluation in retrieval phase. We're going to measure how well relevant documents are fetched. And we can use different metrics such as precision, recall, etc. We can go and do the evaluation in generation phase. We're going to measure how well the system generates relevant, coherent, particularly, and accurate response. And there are different metrics already defined for this. We can also assess end-to-end performance and ensure the retrieved data is used effectively in the generated output. So we're going to measure hallucination rate, we're going to check for the factual consistency and answer relevance here. And also it is important to check and evaluate the user experience here.
Nilu, I see a question that from Sandeep here in the chat asking, how is it determined that relevant information was missed? Can you go into that a little bit?
Yeah. For me using the evaluation method, one of the evaluation method would be human evaluation. So, maybe a person who's expert in this context, they can look and evaluate that. There are some other evaluation methods that the machine can do for us. We can ask LLM to do this evaluation for us, and something that we can do, kind of a very routine method of evaluation, is having specific answers in questions and have a true answer for each, and then run RAG and find the answer that RAG is created and give all of them to LLM to do this evaluation for us. And also we can ask a human to take a look and do this evaluation for us. So it would be one method of evaluation, but still it's very time consuming because we have to just go and create those questions, answers, all those things. Sometimes, maybe you can use the expert who's very familiar with document. That person can take a look. Sometimes you can provide some of the specific information for your agentic AI or to LLM to do this evaluation. And sometimes there are some framework already available that they can do some of those works for you via their own pipeline, and they can do some fact checking and citation tracking, etc. as well. The best way of doing evaluation is a hybrid approach that we combine them. And the best way is combine some of those machine approach with human evaluation approach. So it's good to have both. Did I answer your question?
Thank you.
Okay. Those are the RAG pipeline that we talked about: document ingestion, loading the document into our system, chunking, embedding, vector storage, retrieval, context construction, which is kind of turning retrieve chunk into a structured good prompt for LLM. Maybe we can, for example, something that we can do in this step is removing duplicates, drop some low relevance chunk, compress or summarize if we need. Also, we can add some labels, label sources, other information to that, and then send it to LLM, into LLM generation. So document ingestion, chunking, embedding, vector storage, retrieval, context construction, and LLM generation are the steps that we need to design for our RAG pipeline. And as you see, it's going to be a very complex work to do, right? So if we're going to build a RAG system manually, it's going to be a complex, very time-consuming task. The good news is there are some pre-built pipeline and frameworks available that you can use that. So those codes already created and can introduce to you as a form of function. You can just call those functions and add those parameters for those functions and design your RAG. It's not going to be that simple, but it's going to be improve the path. So instead of writing 100, 200 lines of code, you just need to write down maybe 20 lines of code. So makes everything much more simple. Okay, let me go through this first. So there are different frameworks that you can use. I use LangChain, but I just learned about Llama Index, and it's said that the easiest full RAG framework for beginners. So you can just use that one instead of writing old codes. So what is Llama Index? It's a RAG framework. It simplifies building RAG system. It provides tools, all those functions for ingestion, indexing, retrieval, everything. The good things is it works with all major vector database and LLM. And also, the good part is it has also agentic capabilities. And it's going to handle many things. But the good things is you still have control over some components, such as embedding model, vector database, chunk size, chunk overlap, number of retrieved chunk, etc. Here you can go to the Llama Index webpage and look into the documentations available there. I think it has building function for all those steps: loading, indexing, storing, querying, and evaluating. So this is the example. For example, you can just go from Llama Index embedding Hugging Face, you import Hugging Face embeddings, and then it's the function that you can use to introduce your embedding model as a parameter here. You just need to just copy paste the embedding model you're going to use here. Or when it comes to chunk, you can import sentence splitter, and here you use this function, sentence splitter, and then you're gonna just add this parameter as your chunk size and, for example, chunk overlap.
And I just want to point out that this answers a question that Ronald had asked in the chat earlier about whether you could have overlap that would include neighboring chunks. So this is how you would do that, Ronald. And we've got about 5 minutes left. So if we want to kind of move on to a question time, that could be good too.
I can be very fast on the rest. So you can define your so the question is, okay, how we gonna use it? One way is to use RAG as a tool, and you're gonna define your pipeline, and then you're gonna define this RAG as a function. After you define your pipeline, the RAG pipeline as a function, then you're gonna define this function as a tool using some of this tool framework. For example, I think it's from LangChain. You just introduce here your function name here and provide some description for your tool. And in this very easy way, you just introduce your tools. And then here you can go to your definition in your code for your agent, and you introduce your tools here. You may have multiple tools, so you're gonna add this and have them in one place as a list. Then they're gonna bring it here when you're gonna define the agent. And you're gonna put it there, define your tools here, your RAG is included, and go for the rest. And yeah, maybe there are some, I may skip the rest, which is almost about the cost and how we can create this pipeline as free. Maybe I can skip that one and we can go for the discussion part.
Thank you so much, Nilu. This is a great resource for folks who are just getting into RAG or looking to develop their strategies even further. Does anybody have questions?
If no one does, I had typed the one about the overlap, but my question was actually more if the state of the art had moved to where the chunks could vary and more constrained to like how humans use the information. So for instance, be by paragraphs or parts of paragraphs, so that you would expect the content of interest to vary or sorry, not vary by chunk, or I'm not saying that quite right, to correlate with the chunks rather than there be misses because chunks are limited to a window of observation size that's like locked in no matter what the original content would lock meaning to, if that makes sense. I'm just wondering if there are any transformer models that handle that, and so embeddings that provide that.
Yeah, there are already some kind of framework that is provided for you. You can select this based on the sentence, the paragraph, or chunk. So it's not always, when you go to this framework, you have to look to see if it's created the option for you that you can select your chunk based on the number of token, or you can also specify sentence by sentence, or you can say, okay, let's do it paragraph by paragraph. And if those things are not available in a framework that you use, maybe you can do the coding yourself from scratch and add this component there. And those all of the things that you have flexibility over that.
Awesome, thank you.
You're welcome.
Anyone else? Right. Yeah, we got to a few in the chat as well, but if folks have questions as you're digesting this, feel free to reach out and I can pass those along to Nilu. And the recording will be up on the YouTube channel shortly. So feel free to revisit that as well. And thank you so much, Nilu, for this. I learned several things I did not know. I always appreciate when that happens. Happy holidays to everybody, and we will see you again in the new year. Be safe, be well, and looking forward to more good times. Take care, everyone.
Thank you. Bye, everyone.